So yesterday we focused on the super x when our a term was 1, right? Today, a is not going to be 1. But before we even look at that, let's go back to our list, and we're going to write this 100 times because some of you still don't pay attention or still going to forget. What is the very first thing we do when it comes to factoring? GCF, always. We've literally written this list now, I think, 3 times. Okay, we look at GCF. If GCF works, great. If it doesn't work, what do we move on to? Super X. Now the nice thing is we're still using the Super X today. Okay, we have one additional step with it, but we're still using the Super X. Before we use the Super X, what did we identify? A, B, and C, because we need to then be able to fill in the Super X appropriately. What goes in the top of the Super X? A times C. That's important. What goes on the bottom? B. This top part here? A and whatever your variable is, we're going to call it X for now. And in these 2 spots, your factors, right? Whatever multiplies to A times C and adds to B. Okay, that process is still the same. So we're going to kind of jump right in, and then I'm going to show you where things change a little bit. So we're going to look at 2x squared minus 7x plus 6. 2x squared minus 7x plus 6. Okay. So first thing we're going to look for, just because we need to get in the habit of it, is a GCF. Is there a number that goes into 2? And before I even ask you that, if we can make this 1, our life's a whole lot easier, right? We reduce our numbers. But is there a number that goes into 2, -7, and 6? No. Okay, so we can't pull out a GCF, which means we're going straight to the Super X. So step 1 of Super X is to identify your variables. What is A? 2. What is B? And what is C? So far the same as yesterday? Okay, so let's draw our X. And we're going to fill it in. The top part is A times C. So 2 times 6 is 12. On the bottom is B, which is -7. On the top is your A plus your variable. Okay, so the only math we've done at this point is 2 times 6. Everything else has been a fill in the blank. Okay, same steps as yesterday. I need to think of 2 numbers that multiply to 12 and add to -7. Go ahead, Connor. -4 and -3. So let's check. -4 times -3 is +12. -4 minus 3 is -7. Okay? Now here's where our additional step comes in. If I cover up all of this, what does that look like to you? Does that look like a fraction? 2x over -4? Yeah. Everyone see that? What do we do with fractions? We simplify them. Can I simplify 2 and -4? Yeah. By what? By 2. So 2 goes into itself once, 2 goes into 4 twice. Okay. Now this side's also a fraction, but can I simplify that fraction? I have 2x over 3, -3. I can't do anything there, right? Okay. So the only step now is if you have a leading coefficient greater than 1, you have to reduce. But this is still going to be my factor. So x minus 2 and 2x minus 3. So you need to make a note to yourself somewhere that if you have a leading coefficient, so the number out front greater than 1, we need to reduce the sides of the super X before we write it into factored form. So figure out how you want to write that so you remember to do that.
That's a great place to use a different colored pen or a highlighter after you write it, something that stands out.
And real quick, why did we not do that yesterday? So if I had 1x over 6, why did I not reduce it? Because you can't. There's a 1. You can't reduce that 1. Same here, right? So the reason we're reducing is because that number out front is greater than 1. But everything else stays the same, which hopefully makes it nice, right? We're not adding too much to what we have to do. One more together? Yeah? Okay. Oh, on your own? You're already ready? Una más together. Okay. If you think you can go on your own, I'm moving slower than you probably would anyway. So, step 1 is what? GCF. Is there a number that goes into 6, 19, and 15?
3.
Oh.
We're going to go with no?
Yeah, no.
Okay. So we know 6 doesn't, 2 and 3 both don't, so we're going to leave it as is. Okay, so identify A, B, and C. So A is 6, B is 19, C is 15. Okay, so on top, 6 times 15 is what? It's a big number. 6 times 15. 90. On the bottom is 19. And then we have 6x and 6x. So again, the only math we've done right now is 6 times 15. That's it. Now I have to think of two numbers that multiply to 90 and add to 19. I heard the few of you, and you're right. Is everyone else 10 and 9?
Yeah.
We're noticing that. And if we can't figure it out, we start at 2 and we just kind of work through. So 10 and 9, and we can check. 10 times 9 is 90. 10 plus 9 is 19. Now before we write it in factored form, our last thing to do is simplify. Is there a number that goes into 6 and 10? 2. So 2 goes into 6 3 times, 2 goes into 10 5 times. Is there a number that goes into 6 and 9? 3. 3 goes into 6 twice, 3 goes into 9 3 times. So factored form is 3x plus 5 and 2x plus 3. And how do I check this if I'm not sure if I did it right? Distribute or box. Okay, you ready to try one?
I think I am.
You think you are? So 3x squared minus x minus 4. No, it will. There's the answer to the problem you just did that I paused. Okay. Now I'm going to give you an option. We can do this next problem together, or you can try it by yourself. And I will tell you that there is an additional, it's nothing that you haven't learned, but there's an additional piece than just these first 3. You don't know. So why don't I show it to you and then you can decide. I think you should try it personally.
Pay attention, this is a new one.
Yes, you have to write this one.
Haven't seen this one.
Okay, so some of you are already like going for it. You think you can go for it? Let's see how far we get, and Mr. Garza and I will be around to help. I need someone to raise their hand and tell me what their first process was. Go ahead, Mario. What's the first thing you did? Okay, so Mario searched for a GCF, and he found that the GCF was 4K. Because they all got a K. And what else indicates that there needs to be a GCF pulled out? The exponent of 3. Because what's the highest exponent we can have for a super X? 2. We'll learn how, you won't learn this year, but you'll learn how higher exponents can go later. But right now, we're just dealing with quadratics. Okay? So, when I pull out that GCF, I'm left with 5K squared plus 9K minus 18. Now, some of you stopped and boxed that answer, but remember, you need to keep going if you can. So here we're going to identify our A as 5, B as 9, and C as negative 18. 5 times negative 18. Negative 90 and 9. And then I have a 5K and a 5K. So two numbers that multiply to negative 90 and add to 9. 15 and negative 6 is what I'm hearing. 15 times negative 6 is negative 90. 15 minus 6 is 9. Is there a number that goes into 15 and 5? 5. So 5 goes into itself once. 5 goes into 15 3 times. Is there a number that goes into 5 and negative 6? No. So K plus 3, 5K minus 6, and don't forget the 4K out front. Oh, I guess that's going to be the bell, isn't it? Okay, your homework will be on Google Classroom tonight.